Good to see everybody. I think this is the first Ember ATX that I've been to this year. And man, is anybody going to EmberConf? Yeah, nice. It's exciting. It's like right around the corner. My name is Charles. That's me on Twitter. I work at a place called The Frontside, and we study UI, and our framework, one of our favorite frameworks, is Ember. And as Ember developers, you might have done something like written this code before. Has anyone written code like that before? I'm guessing, yeah. I'm guessing so, because when you're writing Ember, when you want to manage a Boolean value, that's the code that you write. And it's very common. And so, you know, that's what we do to manage a Boolean value. And so what exactly is a Boolean value? It's not a complicated thing, it's intuitive, but let's step through it. A Boolean value is something that can either be true or it can be false. This is where I get to use my laser pointer. It can be in one of this state, true over there, or it can be false, which is not true.
Point to that.
Yeah, you want to get? There's two states right there, but that's the entirety. That's what it is. Those are the only states that a Boolean value can be in. It's finite. It's two. It's very knowable. So we'll use this as our case study. And so we know also not just that it can be in these two states, but we know the operations to transition between those two states. So for example, one very common one, the one that we saw in that slide before, was you can toggle a Boolean value. That's something you can do with any Boolean value. If you've got it, you can toggle it, and that just whatever state it's in, it's going to move to the other state. So if it's in the true state, you toggle it, it's going to move to be false. If it's in the false state and you toggle it, it's going to be moving to true. And that's just something that we know. That's just something that's implicit to Boolean values. There are a couple of other operations that you can do on a Boolean value. So you can set it explicitly. So if you're in the true state, oh man, I'm just going to use this pointer again. If you're in your true state and you set it to false, you move to the false state. But if you're in the false state and you set to false, well, you're going to stay in the false state. No surprises there. And we can round this out by saying if we're in the false state and we set it to true, it moves to the true state. And if we're in the true state and we set it to true, it moves, it stays in the true state. And that's it. Like that is everything that there is to be a Boolean value. Like there is no more, like zip, nada. That's all there is. Like this is what Boolean values were 19 billion years ago. Like before, the universe was created, Boolean values. We're sitting around there hanging out, just waiting for life to evolve so that we could discover them. And when our solar system is destroyed by the sun, turning into a red giant, Boolean values, they're going to be there hanging out, laughing at us, and being like, I am eternal. They're going to be around a long time after you and I are just particles in the solar wind. A Boolean value is a Boolean value. I think we've covered that. And the transitions that you see on that chart are the transitions that define what a Boolean is. So the point that I'm trying to make is the do not change. Those do not change. That's what they are. And so if we know that they're not changing, that those are the operations of a Boolean value, then why on earth are we rewriting those transitions from scratch every single time that we try to use it? Because that's what we're doing right here, right? We're basically pasting that same boilerplate logic into our components or our controllers again and again and again. And you might be thinking, come on, let's put on the brakes here. We're talking about Boolean values. It's not that big of a deal. Chill, Charles. And if that were like if that's where the story ended, that would be fine. I'd buy it. But the thing is as your data types start to get more complex, and those states that define the data type get bigger and bigger, well, you see the same boilerplate point up again. So here we're managing a list. In this type of code, we see again, again, and again. And so anytime that you show me some set of actions that's acting on a piece of data, well, I can show you a state machine that's going to enumerate all of those actions. And whether I'm writing on the board or whether I'm writing it inside of Ember code. Because those are the ones that we're writing out by hand. And when we write this boiler code, is there a way to compose these things? Like what if we want to do something to manage a list of Booleans? Here we have two well-known data types, right? You might actually see something like this, where we're going and munging through this kind of ad hoc data type. And we're basically stuck doing it by hand, even though we know exactly what the state transitions are on a Boolean, and we know exactly what the state transitions are on a list. And so these are just moderately complex data structures. What happens is their data structures get more and more complex. It's kind of become bounded by the way you can manage this code inside of your actions. So what if we, instead of having to kind of have a recipe book for our state transitions, because that's essentially what we're doing inside of our actions, what if instead of having this recipe book from which we kind of drew code and pasted it into our components, what if we had a standard library by which we could declare, oh, I've got a data of this type, which implies this set of actions, and I can then compose those together. And that's really when you have, whether you have a piece of data and the implicit actions that act on that data, you have what's called a strong type. And strong types can be static, they can be dynamic, but the point is you have your data and the operations are finite. And they're known ahead of time, and you can leverage those whether you're a compiler or whether you're a programmer to do really cool things. So the basic technique is that I'm going to show here, and this is only one way to do it. I don't want to get focused on the actual library, but the basic technique is to attach actions that are data that are attached to the data that comes into your template. And what that means is that if I know the type ahead of time, then I can derive the actions, and I don't have to write them. Because those actions are implicit. So let's actually see this in action. So I am going to do a little live coding here. And so here we have a little context menu that I wrote. And we're going to see is using strong types awesome in your Ember application. So here I have a context menu, and what I want to do is have this be a toggle and have this close, and then we'll wire up some nice data to these checkboxes here. Right now this doesn't do anything. I can click on this button, I click on this button, nothing happens. It's just statically open. And if we look at the template, I have this Boolean value so that it's always showing. It's always going to be showing that drop-down menu. But we know it's a Boolean value, so let's go ahead and allocate a Boolean value. And we'll start it out as being false. And then what we can do is we can say, if it's open, then we'll do it showing. And if it's closed, then it won't be showing. So now when I reload, you can see that it's not showing. And lo and behold, when I click, nothing happens. But that's because we haven't actually wired up any actions. But we know because this is a Boolean value, right? What can we do with a Boolean value? We can toggle it. So every Boolean value can be toggled. It is true.
Or false.
And so now, if we click it, you can see that it actually shows the dialog because it's tied to that CSS class. And furthermore, because we're toggling it, when I click it again, it shows it. Now what about this one right here? We don't really want this one to toggle. We want this one to always, no matter what happens, when we hit the close button, we want it to always close the pop-up. So, but that's no problem. We can do the same thing that we did there, except we can just explicitly set it to false. And so no matter what happens, when we click that button, it should, yeah, it will always close. Now this one is a toggle here, and this one is a closer. And we can get pretty fancy. There's actually a lot that you can do with the Boolean. You can, suppose we wanted to make this a hover effect, so that every time you moved the mouse into this button, it showed, and any time you moved it out, you wanted it to close, right? So you have an open and a close operation. Well, we have a component called pointer events. This is something that I wrote here. It lets you bind arbitrary actions to pointer events. But the point is that I can do something like on enter, we can say action is open.setTrue, and on leave equals action is open.setFalse. And what that is going to do is anytime that I enter that area, it's going to open, or it's going to set it to true, and anytime I leave it, it's going to set it to false. So now you can see if once I move the pointer device in there, and I can stay inside here, as long as I'm inside, it stays open, but then the moment I move out of the context menu, it closes. This thing still works as a close, this thing still works as a toggle, but now I've actually, with one Boolean value, I've been able to control its inputs at all points because it's just Boolean, right? I just am telling when do these actions happen on it. So that's a Boolean value. We can look at some more advanced things. So one that I really like is called select. And so this just instantiates a distinct select type. So a mutually exclusive selection. So if I have a list of 3 elements, let's see. If I have a list of 3 elements here, then I should be able to select one of them. Now, right now, it's actually not wired up because what I have to do is actually say what happens when I click those things. So what I can say is, option action .toggle, because the options of a select, it's implicit. You can toggle them. You can set them on and off. That's just that's what they're about. And I can also do, if it's checked, it's going to be checked if the option is selected. And again, those are, this toggle action is implicit to every option. So now I can toggle those and it becomes a mutually exclusive select box. And the nice thing about that is is that I'm dealing directly with the data. Okay, I've just got this data. I have the actions which are implicit to that data, and so I'm able to generate those state transitions just by mapping HTML events to those state transitions. And that the presentation doesn't mean anything. I could make this a radio. button, and it still has the same effect. And or I guess I could even make this a drop-down list if I wanted to. We could try that, actually. Let's see. We're going to try this. We would want to make it, what, a select element? And then let's see if this works. For each option, we'd want to generate a option. Name equals option.value. Checked equals I actually have never tried this before, so I don't know if it's going to work. And then, what is it? Do you get an on-click with this?
We'll find out.
Let's see. Yeah, I thought oh, there we go. It's giant, but it didn't help.
Label 113 is the key for me.
On 13?
Yeah.
Wait, what? Oh, pull it out. Okay. No, I've got a unclosed element option.
You have the option, the blocks,
Oh, okay, wait, oh, you know what?
and then your name isn't yet.
I see.
And then value equals. Value equals option value.
I think, let's see. Yeah. Anyway, the point is that you have that data, and so you can represent it however you want. You can do the transitions on it however you want. And that's pretty much it. That's what I wanted to show in the code demonstration, and why we can take questions about that in a little bit. All right. So, you guys saw that demonstration. You might actually be thinking to yourself, like, okay, that was pretty weird. Did I just like totally put way too much logic in the templates? There's this, there are a lot of people who say like, you gotta be no logic. What I'm doing this stuff in my templates. And so you have to ask yourself, the question is, what I did I put logic in my templates? Was that logic? That wasn't really Boolean logic. It's a reasonable question, but my take on it is no, this is not about logic. This is not about putting things in your template just for putting them in your template. This is about the actions that you do not have to write at all. So this is not a transference of one thing to a different place. This is the erasure of actions completely and totally from your components. It's less code, it's less maintenance, it's less to keep in sync, and it's going to be more robust in the long term because of that. Because if you look at this, if I have action with some string toggle open, where the hell is that going? Like what is that derived from? We have no idea where, in this conception, which is all I really did, is I just changed where the action was dispatched to. Here it's very clear. This is the toggle action. Sorry, let me back up. This is the toggle action, which belongs to the Boolean value, because every Boolean value has a toggle action. It's just the way it is. And so we write our applications with essentially weak types is what we're doing. We have this unstructured data that we just kind of throw over the fence, and we kind of sit there and we're like, okay, let's take this data and let's munge it, but we're not actually using anything about the structure of the data to make smart decisions. And this is certainly this is how Ember actions work, but this is exactly the same problem in Redux too. Every time you write a reducer on unstructured data, you're basically using a weakly typed system. And so I think that if you're using React or Redux, I think this equally applies. Because why is this necessary? Why do we have to do stuff like this? And why the hell do we have to do stuff like this? That just seems like a big no-no. But if you actually use strong types, if you actually have type information at runtime, you can make smart decisions because you can see into the structure of your UI. And by virtue of the data that you're using, you know how you can act on it. And that means repeating yourself less, breaking less, and it ultimately means, as you strive to build better interfaces, you can reach higher. And so I hope I've given a taste of that today. So thank you. We are hiring at the front side. So come see me, and that's it.
Questions?
Questions?
What library are you using to strongly type things?
So the library that I used here was one that I wrote called Ember Microstates. And it's based around this idea of using strongly typed data so that you can infer the actions. I think it's on my GitHub repo, and I'll include the link to it. There's a full API. There are constructors for lists, for select items, for Booleans, for all kinds of stuff. All kinds of basic data types. So by all means, go have a play. There's a lot of demos, so you can kind of see more of the things that I was doing.
So if I wanted to start doing this, I essentially need to use a library. Like, is there another way that I could start doing this, like I've heard of Typescript?
So Typescript is a similar concept, except the person who gets to use, the person who gets to benefit, or the thing that gets to benefit from the type information is the compiler. But in this scenario, the person or the thing that gets to benefit from the type information is you. And so yes, you can have a very, JavaScript is a strongly typed, strong dynamically typed system. TypeScript is a strongly typed, statically typed system, and we use both of these tools to build weakly typed systems, and I think that's what's wrong. Like, I think that's part of the problem. We have a lot of pain. We have to write a lot of boilerplate because of that.
How does this, like when you use this, impact your testing? It seems like in some ways it would make testing easier.
Yeah, so
Less JavaScript that you're worried about.
Yeah.
Screwing up.
Yeah, no, you don't have to test these actions explicitly. I mean, you still want to do acceptance testing, but yeah, it just, because the action is the action is the action. You don't have to. How many times do you have to test a toggle?
The other thing that I really like about this approach is it keeps all of the actions in your component that you have in your component are the things that you actually care about.
Mm-hmm.
Instead of just toggling properties.
Yeah.
Mm-hmm.
So where do you find that line, Charles? Like, where do you find the line between, what things need to be just like these actions that are in your template and not going so far as to having, all of your logic in your template?
So, I feel as though things like, well, I've carried it so far as tracking kind of local UI state. So I think there was a talk that Michael North gave where he was talking about the different types of state that you have in your Ember application. And he talked about, there's kind of like local UI states. So things like select lists and checkboxes and position and things that are centered around the presentation and really don't escape outside the scope of your component. And so I found that it's very, very comfortable to use this with very little problems using something like this. If you've got state where your transitions are actually, maybe reaching up and affecting some higher, more primary state that could affect, I haven't really experimented. I mean, I think that it seems like it should be theoretically possible. I mean, you could use this technique to maybe do something like, map to actions that ultimately are stored inside of a Redux store or something like that. And so I think that's possible, but I wouldn't say like lean on it. But like certainly for local UI state, man, it's really nice.
Have you used this pattern with any kind of Redux or React?
No, no, nope.
Do you plan to?
I do.
So let's say I'm filling out a form and I want to use this and thinking like a
gender, male, female, fiance, answer, whatever. Is that something you would use it for? Like, how does this data action back up? Like, how do I send it back up?
So,
It lives in the template.
right. So what you can do is the local state is just stored inside that one value. But then if you want to, and so the initial value that you pass into the constructor comes from that persistent state or that primary state. Then it can transition locally however you want it, however you wire up the events. And then when it's time to save or do some sort of action, you can then pass that value along with that action, and then that gets applied somewhere else.
It's tough to do validations on it, though, right?
What do you mean validations?
Like if you're validating a form, sorry, it's like
No.
if you're validating a form and all your data lives in your template, and typically validation doesn't happen in the template, right? Validation happens at the component JavaScript level,
Right.
or at the controller. So
So validation usually happens, validation ultimately derives from the values that are stored in the DOM, usually. So these are actually ultimately manipulating those values that are in the DOM, which then feed the validations. So it should work pretty side by side.
What about, like, compared to something like Ember composable helpers?
So Ember composable helpers. So this is actually that's a great question, and I think the difference between this and Ember composable helpers is that Ember composable helpers is all about deriving new state from existing state. So I have some state and I want to derive new state from it. What I've shown here is you have some state and I want to transition it to a new state, from which then I can derive new state. But that's the difference, is Ember composable helpers is nothing but computation of new state, whereas this is more about transitioning the state which then can be derived from. So they're actually very complementary. Huh? All right.